feel the vibe.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we wrap up our work with the geometric sequences in series. In this video, we're going to take a look at applications of geometric sequences. So if you have not yet taken a look at the previous videos covering the introduction of a geometric sequence and the nth formula as well as the nth term formula as well as the partial sum formula, make sure you watch those so you have an idea of the concepts that are going to be applied here. Let's jump right into an example problem. So our application is going to be a bit of a word problem. In problem number 8, it says a pendulum is an object attached to any fixed point and allowed to swing freely under the influence of gravity. So you might think of maybe like the pendulum on a clock. So it has like some kind of attachment and some kind of circle here, and it goes back in an arc shape. Suppose each swing is 0.9 times the length of the previous swing. So as we go back and forth, it's gradually reducing how far it's traveling because gravity is affecting it. And so it's unable to swing in the full range of motion. So that sketch kind of roughly displays how far that pendulum would be traveling. Gradually, the path of the object will become shorter and shorter, and at some point, the pendulum will appear to have stopped. Now, if you talk physics, there's always some kind of motion, but visually, it's going to stop, as we can see. In problem part A, it says, how far does the pendulum travel on its 8th swing if the first swing was 2 meters? So what we see here is that each swing is going to be 0.9 of the previous swing. So let's say the first swing, let me draw this slightly different. Let me draw this over here. All right, let's see this is at the top of the swing here. And let's say that it swings and it travels that distance. And that distance would be 2 meters. And then from there it comes back down and it travels, but it doesn't get quite as high. Close, but not quite as high. And this distance would be 0.9 times 2 or 1.8. And then it would swing back and it wouldn't get quite as high as it did the previous time. And so this would be 1.8 times 0.9. And this would be 1.62 meters, and so on and so forth. And we'd follow this pattern. It'd keep doing this, okay? In B, it says, how far does it travel on the 8th swing? Well, what we can do is we could keep multiplying by 0.9 to find all of the swings. We found 3 so far. Or we could use our nth term formula here. So really what I would be looking for is the distance of the 8th swing, which would be the 8th term in this geometric sequence. So I can find that by using the first term, 2, times the common ratio that they gave us was 0.9 to the n minus 1 or 8 minus 1 power. So if I take 2 times 0.9 to the 8 minus 1 or 7th power, we can see this decimal approximation would give us the length of the swing. So let's go ahead and round this to 2 decimals. Let's round this to 2 decimals. And this would travel approximately 0.96 meters on the 8th swing. In problem B, 8b, it says, what is the total distance traveled? So across the 8 swings. So what we could do is we could take this 2 meters and add it to the 1.8 meters, and that would be 3.8. That's the total distance over 2 swings. And then add that to 1.62, so that would be 5.42 meters, and that would be the distance. 5.42 meters. That would be the distance after 3 swings. And we could keep adding those. Or we could go ahead and use the series or summation formula here for geometric sequences. So we would be looking for a partial sum of the first 8 terms or the first 8 swings. We know the first term is, or the first swing is 2 meters. We know that the common ratio would be 0.9, and this would be to the 8th power, as we're looking at 8 total terms, or 8 swings. And then we can divide this by 1 minus 0.9. So this would give us the total distance that this pendulum would swing as we go back and forth and back and forth. So I can take 2 times 1 minus 0.9. Sorry, let me type this in correctly. 1 minus 0.9 to the 8th power. And divide this value by 1 minus 0.9, which is 0.1. And this would give us the approximate total distance. So this would travel approximately 11.39 meters in total over 8 swings. So here we just see both of the previous formulas we have learned, the nth term formula for a geometric sequence and the partial sum formula for a geometric sequence, put together in some application with a word problem. As always, thank you guys for tuning in, and I'll see you soon.